Here we go, I forgot part C here. For part C, you have to find the domain of g of x algebraically and verify your results from part B. So if you look back, part B, we have to find the domain of g of x. So we're looking at g of x. If you remember the domain, if you look back here, the domain of g of x was 0 to infinity, right? So we already know the answer. The domain is from 0 to infinity. We know this graphically. We have to verify this algebraically. If you remember, algebraically means with algebra, right? So we have to first write g of x. So g of x is equal to f of x squared. And f of x, as you know, is just the square root of x minus 3 squared. So now we just have to simplify this problem. So we're going to square this out. So what do we get? This becomes here, if we square this out, this is going to be, this means this times this, right? So if we FOIL this out, this square root of x times square root of x is x. Square root of x times 3 times negative 3 is negative 3 square root of x. Negative 3 times square root of x is negative 3 square root of x, and negative 3 times negative 3 is plus 9. Gotta combine like terms. So what we get is x minus 6 root x plus 9. And now what we do is this is g of x here. Now note, all I did was I just FOILed out what this said over here. So all of this is just g of x here. So the question is, how would I find the domain of this one? So you have to look at our functions here. So if you look at this over here, x, let me rewrite this actually. Well, it doesn't really matter. Well, the only thing you really need to worry about is not x, because x is linear. So this domain is all real numbers, right? 9 doesn't do anything to the domain. The only thing you have to worry about is this guy, the radical. If we know we have a radical, this means that everything inside here has to be greater than or equal to 0, right? So what does that mean? Well, so we solve this here. We graph this out on the number line. This starts at 0, right? And it goes this way because 0 is pointing this way. And in interval notation, this looks like 0 to infinity, right? Which is the same thing as we had from the part B. So all we're doing is we're verifying what we had in part B, which is what part C asks us. It says, find the domain of this algebraically and verify your result from part B. And that's what we did here. If you didn't want, so just note here, we're just doing this with algebra here. If you also wanted to, you could have just checked this out and said you've done the same thing here. Because if you notice, the only thing that matters is this here, and you could have done it at this stage. And just set this one greater than or equal to 0. And then just done the same thing that we did over here. There you go.